No. Thank you. Can you hear me? Am I coming through on the live feed thing? Awesome. Wonderful. This is going to be very quick because I've got like 20 minutes to tell you about some ridiculously silly cool stuff that we've been doing in WebVR and Matrix. First of all, who knows what Matrix is? Pretty much everybody. Brilliant. I can skip the boring bit. So like the two people who don't, we're an open decentralized network for real-time comms, and critically we're going to talk about open comms on VR AR. I sound like I'm clipping. Is there anything I can do to not clip, or is that sorry for people online who can hear horrible distorted Matthew. I'm going to skip the boring stuff. There's Matrix, no single party owned your conversations, blah, 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 Matrix architecture. Here's a quickly new version of the ecosystem diagram, which is showing a lot of third-party clients out there now. We've got the Matrix spec, we've got servers, we've got the clients from the matrix.org team in green, but we've also got lots and lots of community projects on purple now. We have Neko on Qt, Quaternion, Fest, Fractal on GTK and Rust, Thunderbird, WeChat, many, many other clients, and also other third-party community servers in Rust and Java and all sorts of exciting languages there as the Matrix ecosystem basically is growing. But the whole idea is to basically disrupt WhatsApp and Slack and all of these big silo services by building an open network for communication. Now, AR, VR, there's basically no interoperable communication layer today. And one of the things we'd love to do in Matrix is to provide a way for people to talk, whether it's by VoIP or video or just a kind of decentralized interaction layer for AR and VR. Now, we worked on this last year a little bit and basically built a demo that you can use right now, in fact, on matrix.org/VR demo. Now, let me try to find one I made earlier. That's not it. Where's the one I made earlier? Too many tabs. How about I open up a new tab? Okay, so let's go to matrix.org VR demo. And yeah, this is looking promising. And what this lets you do is to do some VR conferencing. It also does 360-degree video with a WebRTC call embedded on it. And well, probably the best way to show it is to hit the Go VR button and hope that we have enough net access to re-download all of the WebVR stuff. Now, this is totally normal Chrome. Also works perfectly in Firefox. And what you see yourself in here is a Star Trek: The Next Generation Season 2 holodeck. Where you can wander around this. This is a Clara model where you can go out and view the beautiful HTML background wallpaper. We can go in, and you can see this chap here is welcoming us to the room, and this is just a video clip. If I go and click on the red button here, though, I get a couple of things. We can do the 360-degree demo, or we can do a phone box, which will take us into the VR, the conferencing demo. I'm going to risk the VR one and jump into it like so. Takes me back into the room here. And hopefully, now we've got a table here. And it's got a Matrix room URL, which is vrvc female guanaco on conf.matrix.org. But currently, I'm the only person in here, except Amandine, who's down there in the audience. Hello, Amandine, has just joined it. So what we're doing here is having a WebRTC call, which has been negotiated over Matrix, and this room is basically a VR manifestation of a chat room in Matrix. And what else can I show you here? I mean, you can see the frame rate's pretty good. Something that could be a lot more fun, though, is that we can take an Android phone, like this crappy old S6, which is probably run out of battery. No, it's trying to upgrade itself. That's perfect timing. Thank you, Android. Perhaps I will install overnight. And let me go to the same place here on Android. I'm a dirty iOS user, I'm afraid, so this is always a little bit risky at this point. Right, sorry, let me just get the thing up on it. So I'm going to the same URL, matrix.org VR demo. Hoping that the Wi-Fi is going to be up for it. Oh, hello. So that's Michael down there, who's gone and joined the room on the Matrix side, and you can see that his going in there. Amandine, is your video cracked out? Where did you go? Oh, I'll see whether I can join it from here. Irritatingly, my Android phone is trying to take me onto a different room, Silver Condor, not to be confused with female guanaco. Anybody know what a guanaco is? No. I think it's a type of llama. Yes, there we go, thank you. It's the third largest member of the South African cameliid family, I think. And, next to the vicuña and the llama and the other one. Anyway, I think I've got onto it now, hopefully. Almost. Okay. So I'm going to hit. So I've got the same thing here. I'm afraid I'm not going to be able to easily broadcast this. Oh, there we go. We've got even images being replicated up into the thing there. Obviously, the brightness is now crashing on this to make my demo even more catastrophic. Let me whack it up to there. Yes, it's going to. Okay, so here we are. So we've got the same thing going on here on my phone, and now it's this again is stock Chrome Android using A-Frame as WebVR, and irritatingly, that's not helpful. So in VR, the room is over there. So some people, if I kind of do that, will be able to see the corner of it. Let me try to scrub it around. There we go. Oh, almost there. Oh, God, that's the worst possible positioning. Come on. Yeah, I think it's possible that the scrubbing thing. What I'm going to do is to actually press the goggle button here, which will put it into. There we go. That's now actually working. So you can see a stereoscopic view of the room. And it's a pretty good frame rate, even on a S6. So it's doing about 20 frames a second. And critically, well, it should be now even. Oh no, I need to actually go into the room. So I'm going to hit the blue button so I can get the phone booth up. I'm going to tap on the phone booth. Come on, work, damn you. Well, basically, it actually works surprisingly well here, and the idea is that you go and take a VR headset like this, and you go and plonk it in there, and you can get the call up to, let me just try to get into the room. Yeah, the problem is that the hit target is, for some reason, not registering on there. It's annoying because we tested it a minute ago, and it was great. And it probably also doesn't help that I'm in the wrong room. Let me just try this quickly one more time. Bear with me, it's going to be amazing. This isn't even the real demo, by the way. This is showing what we were up to last year as opposed to the 2018 variation of this. Okay, so I'm back in VR on the phone. You'll have to believe me. It's possible that too many people have now tried to go into this conference. This is a problem with using a live demo, which is being generally destroyed. It's so annoying. It's so cool when this works. And the hit targets are even working too on this now. Okay, perhaps we come back to it at the end if we have time. Let me show you the much better demo, the one that we've been, oh God, yeah, it's all happening in here. Little known fact is that you can keep stacking up until you go through the ceiling, which is kind of fun. Okay, so that's the carnage of the female guanaco room. Let's get out of here and talk about what I actually wanted to talk about, which is this. Basically, this was WebRTC in A-Frame, Matrix using end-to-end encrypted communications, and it's a full mesh, by the way, of conferencing there, so you do actually have end-to-end encryption going all the way through. Now, the idea we did this was to show that Matrix is a lot more than instant messaging, blah, blah, blah. Let's skip to the fun demo. The problem is that these were just crappy old, plain old, if you will, video planes, and it's missing the whole point of VR, AR. Putting a 2D video conference into a 3D world is pretty boring. We want to see who we're talking to in 3D. It gives you a lot more presence in the kind of emotional sense. It allows you to fix gaze correction, which is I still think is a pretty big deal, that when you're looking at somebody on a 2D video call, they're looking at the camera, whereas you're looking at them not looking at you. And so your gaze never meets. And it causes horrible emotional gap. Whereas if it was in 3D, you can just position yourself in 3D until you're kind of looking at them. And obviously, hopefully, it should look a bit more real. What we didn't have last year is a camera that gives good 3D depth sort of capturing and video, which is perfectly optimized for 3D video calling with good API support. But then, happily, Apple came out with the iPhone X with its true depth infrared dot projector, which you can see down here on the right-hand side, which is splashing infrared dots all over the place and gives you 640 by 480 at 24 hertz of depth data, perfectly calibrated with a YUV front-facing camera. And I have no idea why nobody has done 3D video calling before, because it's really fun. And this thing here is basically built as a 3D video call device. But as far as I know, nobody's done it. Until now. Hopefully. So we decided to build the world's first 3D video calling using the iPhone X, Matrix, WebRTC, WebVR in 7 easy steps. And first of all, we had to hack WebRTC to add support for depth capture. This is actually pretty easy. You take the AV Foundation video capture and you said, please don't request the video stream, request the depth stream. And it kind of works, which was kind of reassuring. Step 2, well, now you've actually got to bake it into a client. Predictably enough, we used Riot iOS, which is built on top of the Matrix iOS SDK. And luckily, Google now ship a CocoaPod for WebRTC. Riot and Matrix is all CocoaPod based too, so it was very easy to glue into a local CocoaPod. Step 3, now this is where it gets a bit more interesting. So the data that you get off this thing is 16 bits, so half precision floating point depth data measured in meters. So you literally get the stream of half precision numbers, and somehow we've got to map this into WebRTC. Now, there's a WebRTC working group dedicated to encoding depth over video, and they're not going to like this talk because we completely ignored all of it. And their kind of, their first principles is to say, if you're streaming depth, don't treat it as video. Depth is totally different. It compresses in completely different ways. It's floating point versus like 8-bit color and all that sort of thing. I'm afraid that what we did was to go and see that these guys at UCL in London wrote a paper back in 2011 talking about encoding Connect data as depth into video. And they basically said, whatever, take 16-bit depth data and you put, the best way to look at it is this. In the blue channel, you just go and do a linear interpolation. So you basically got coarse granularity stuff in the blue channel. And then on the green and the red, you have a periodic function as a triangle wave with a phase shift that encodes the fine level detail. In practice, this means that if you've got the camera there, it starts off looking very red and green and stripy, and you move it forwards and it slowly gets more blue, and then the red and the green kind of oscillates as you go through the triangle wave, which in theory could be quite a cute way of doing it. The main problem is that it comes out looking like this. So I'm afraid this is my ugly head with a bright blue where it's in the foreground, darker in the background, and you get this lovely kind of moire pattern, which, let's face it, this is kryptonite in a bad way for video codecs. This is the least compressible thing in the world, and I'm not really sure what the guys are thinking of in that paper, because it really doesn't work. So this is the dot cloud that you get off it. It's possible I screwed it all up, but basically, the problem is that you can't encode the twiddly bits around the edge, and when you convert it from RGB to YUV and then back again, it mangles it all up anyway, so all of this fine detail gets put back into the RGB space, and basically it was a bit anticlimactic. I also screwed up by not converting the floating point stuff into a kind of linear integer domain for doing the calculation, and instead treated it like a bit field and did a bitwise cast. So the contrast of the data was basically wrong, which I didn't think was a problem. Based on that, looks like a pretty contrasty image to me, but basically you ended up with this fairly crappy result. Step 5, give up on the fancy depth encoding and say, 8 bits of depth is good enough for anybody, especially if it's between, let's face it, here and here. 256 depth values between there and there, that's good enough. And empirically, here is a beautiful dot cloud of my face in green, showing that, it's not looking too quantized. It looks like it might be all right. Step 6, now, green is great, but we need to have color. So what we need to do is to capture both the video and the depth of this thing at the same time. This is a little bit more fun because WebRTC very much assumes that it controls the camera, and thou shalt only have one camera per capture device. And meanwhile, you need to basically have a way to share the capture device across 2 totally different video tracks. So at this point, we butchered the WebRTC API horrifically for iOS to allow you to share an AV capture session between 2 different capturers. And then it was actually only a couple of lines on iOS SDK to set our new form, very spec-compliant constraint called matrix depth, not to be confused with the standards-based depth constraint. And suddenly, we're starting to get somewhere. It's starting to look a bit more promising, except the dot cloud might have a few limitations. It actually works great if you kind of back away from it in VR and all the dots merge together, and it kind of looks a bit like a 2D video a long way away. But then you get in close to see all the cool 3D stuff, and it turns to crap like that. So, add solidity. Basically replace the dot cloud with a displacement mapped mesh using a vertex shader. Ideally, you'd use a geometry shader, but WebGL doesn't give you geometry shaders, irritatingly. And he switched out for basically an A-frame plane with 640 by 480 vertices using the vertex shader and tweak it to try to reduce some smearing. And it looks like, so we try to do the real demo now. What can possibly go wrong? So here we are, back in a localhost version of the VR demo. And this time I've told it to phone Matthew2 on matrix.org, which I'm logged into on iOS on my beautiful iPhone 10. So let's see what happens here. So we're back in the holodeck. And good news is that this cannot connect to Matrix. This is a really good starting point. Let me pray that this thing is on the right Wi-Fi. Oh, I've got a call coming in. So I'm going to answer the call using Call Kit. And we're on. So here you go, ladies and gentlemen, the world's possibly first ever iPhone 10 3D video call. Woohoo! Okay, let's face it, this is not exactly refined. This is a 2-day hack in the last couple of days in a kind of, oh my god, FOSDEM actually accepted my VR talk, we better show something in VR. But hey, hopefully it serves the purpose. We've got some problems here. First of all, it turns out that's quite a far way away, and you get this amazing tearing effect. Now, what we're trying to do is to reduce the smearing by making it transparent, by looking at the partial derivative of the depth buffer and turning those planes invisible. The only problem is that my graphics card apparently has a really crap partial derivative function going on it, and so only half of them disappear. And I'm sure it's the GPU's fault, and in no way my code to blame that. Then, what else have we got? We've got the fact that the depth signal and the video signal are kind of sometimes getting a little bit out of sync. So if I move it around a bit, actually, oh no, at the moment it's working perfectly. Trust me, you can get like 100 milliseconds of delay between the depth and the video buffer, which ends up being quite trippy because everything sloshes around. Obviously, you want to sync them together. It turns out iOS gives you a nice API to keep them in sync, to properly genlock them together, which I'm not using at all because we'd have to thread it through WebRTC. But it would be nice if it works. Other problems, well, it's basically the rest of the effect not working is the 8-bit depth, and you can see it's a little, it's fine. Oh, we're in the middle of my head. Welcome to my head, everybody. That's what it's like to be inside me. If you go and push through like this, you can see, there's obviously a front clipping plane, which is actually the dot projector running out of juice. But that's relatively working okay. But if you look at it from the side again, we're going to have this weird clipping effect, which is sort of cool. It's very help me Obi-Wan, you're my only hope. But it's kind of even worse quality than poor little R2-D2 could manage, or 3CPO, whichever one it was. So there you have it, basically. That's what I wanted to show you. And the idea is to basically say, this doesn't have that much to do with Matrix, but it's using Matrix as a signaling protocol to do all the signaling. And honestly, the Matrix side of it was a pleasure to use. If you've spent too much time doing WebRTC with SIP or custom HTTP stuff, just having a simple HTTP protocol, we have an SDK, and I don't know whether I've got it open. I don't, but if I opened up Xcode, it'll probably come straight up with a couple of lines of code that show, especially if I hang up so I get some CPU back. Come on, Xcode. Xcode's probably upgrading itself too. Basically, it's about 10 lines of code in the end. But you can check it all out. It's all sitting on GitHub. Next up on VR is basically not to do any VR on Matrix because we need to make Riot suck less, and that's actually the priority. But in future, we want to do world geometry on Matrix and avatars and physics. Meanwhile, on Matrix itself, lots of UX stuff on Riot. We got funded last week, thank God, so thank you to everybody who supported us, but we're also hiring for designers and front-end devs and crypto and Go and Python people, and VoIP people and VR people if you want to get involved. And here are the URLs for the playback side and the capture side of 3D video calling. Thank you very much. Thank you, Matthew. That's right. Unfortunately, we are already out of time. Boo.